Hello friends, welcome to the point. In this session, we are discussing about pipes and cistern. Instead of LCM method, if you are using formula method to solve the problem and you have to learn this formula which is very important. A pipe can fill a tank in X hours. Due to the leak, it's filled in Y hours. Then the time by the leak to empty the tank is. That is given that a pipe can fill a tank in X hours and other pipe can empty it in Y hours. With the time taken to empty the tank. So the formula here is X into Y divided by Y minus X. This is the formula to calculate what is the time taken to empty the tank. Let's solve this question using formula method. There is a leak in bottom of the tank. When the tank is repaired, it would take 3.5 hours, but now it takes half an hour longer. If the tank is empty, then how long it takes to fill the tank? Usually without any leak, the tank fills in 3.5 hours. But there is a leak, so it takes half an hour extra. That is 0.5 hours. That is nothing but now it takes 4 hours to completely fill the tank. So you got the value of X as well as Y. Now use the formula X into Y divided by Y minus X, which is equals to 3.5 into 4 whole divided by 4 minus 3.5, which is equals to 3.5 into 4 is 14 and 4 minus 3.5 is 0.5. For easy simplification, multiply both numerator and denominator by 10. We get 140 by 5, which is equals to 28 hours. If the tank is empty, it takes 28 hours to fill the tank. Two pipes P and Q can fill a tank in 24 hours and 32 hours respectively. If both the pipes are opened together, find when the first pipe must be turned off so that the tank is filled in 16 hours. So it is given that P and Q are the two pipes here, and P can fill a tank in 24 hours and whereas the Q can fill it in 32 hours. So now the capacity of the tank is LCM of 24 and 32, that is 96 unit is the capacity of the tank. Now find in 1 hour how much units of water does P and Q fill. So P fills 96 by 24, that is equals to 4 units of water per hour, and whereas Q fills 3 units of water per hour. So altogether P and Q can fill 7 units of water per hour. We know the capacity of the tank is 96 units and the tank should be filled in 16 hours. That is 96 units should be filled in 16 hours. In 16 hours of time, initially P and Q for a certain time they fill the tank. After that, the remaining part is filled by the second tap. So now write the equation. 96 is equals to P plus Q both fill the tank for a certain period of time. Let's take it as T. And the remaining part, that is 16 minus T hours, is done by Q alone. Now solve this equation. 96 is equals to P plus Q is 7 plus Q's value is 3. 16 minus T. Therefore 96 is equals to 70 plus 48 minus 3T. The value of T is equals to 12 hours. That means the first pipe must be turned off after 12 hours. Two pipes X and Y can fill a tank in 24 minutes and 32 minutes respectively. If both the pipes are opened together, then after how much time should Y be closed so that the tank is full in 18 minutes? This problem is similar to the previous one. Only difference is the time there was in hours, but whereas here it is in minutes. So X can fill a tank in 24 minutes and Y can fill a tank in 32 minutes. So the total units, that is the capacity of the tank, is 96 units. So in 1 minute, X can fill 4 units of water per minute and Y can fill 3 units of water per minute. So both X and Y can fill 7 units of water per minute. So this is same as the previous one. So 96 units of water should be filled in 18 minutes here. So this 96 units of water, it is being separated. That is, initially for a certain period, X and Y both together fill the tank. That is, we don't know the time, so we take it as T, and again X alone does it. So 18 minus T. So 18 is the total time and T work is already being done. So T hours is subtracted. 96 is equals to, substitute the values of X and Y. X plus Y is 70 plus X value is 4. 18 minus T. 96 is equals to 70 plus 72 minus 40. Solve for T, we get T is equals to 8 minutes. After 8 minutes, the tap Y should be closed. 3 pipes A, B, C can fill a tank in 6 hours, 9 hours and 12 hours respectively. B and C are opened for half an hour. Then A is opened. What is the time taken by the 3 pipes together to fill the remaining water? There are 3 pipes A, B and C. A can fill the tank in 6 hours, B can fill it in 9 hours and C can fill it in 12 hours. So the capacity of the tank is, LCM of all these 3 is 36 units. So 36 units is the capacity of the tank. Now find in 1 hour how much water can A, B and C can fill altogether. A can fill 6 units of water per hour and B can fill 4 units of water per hour and C can fill 3 units of water per hour. It is not given that A, B and C all together. Initially pipe B and C are opened. So B and C together they can fill 7 units of water per hour. And then it is given that they work for half an hour. So this is for 1 hour work. So for half an hour B and C does 7/2 waters they can fill in half an hour. So here we had to calculate the time taken by 3 pipes together to fill the remaining water. So here's already 7/2 units of work is done. That is, left out is 36 minus 7/2, which is equals to 65/2 units of water should be filled now. So this 65/2 units of water is being filled by altogether A, B and C. So A, B and C does 13 units of water they will fill for an hour, and therefore 65/2 divided by 13 is equals to 5/2, which can be written as 5/2 or 2.5 hours is the time taken to fill the remaining water. 3 taps A, B, C can fill a tank in 12 hours, 15 hours and 20 hours respectively. If A is open all the time and B or C are open 1 hour each alternatively, how long it takes to fill the tank? There are 3 taps A, B and C. A can fill a tank in 12 hours and B can fill in 15 hours and C can fill in 20 hours. So the total capacity of the tank here is 60 units. So find out in 1 hour how much water does A, B and C can fill. For 1 hour, A can fill 5 units and B can fill 4 units and C can fill 3 units of water. So it is given that A is open all the time and tap B and C are open 1 hour each alternately. So in the first hour, A and B is operating, and in the second hour A and C is open, and third hour A and B, and fourth hour A and C. This process continues alternately. Here A is in all the term because A is open all the time, whereas B and C are open alternately. So A and B can fill 9 units of water per hour and A and C can fill 8 units of water per hour. So for 2 hours, A and B and A and C can fill 17 units of water. Now find how long it takes to fill the tank alternately. That is 60 by 17. 17 3s are 51 and the remainder is 9. So for 1 hour, A and B are opened. For the other 1 hour, A and C are opened. This process continues alternately. So here 3 into 2 is equals to 6. Remaining 9 units of water is to be filled. So which tap fills that water? For the first 1 hour, A and B fills the tank, and for the next hour, A and C. As this process continues, A and B fills the tank in odd hours and A and C fills the tank in even hours. So for 6 hours, A and C fills the tank finally, and remaining 9 units of water is being filled by A and B. Already A and B fills 9 units of water per hour. So this remaining 9 units of water is filled by A and B. That is, other 1 hour is being added extra. That is, within 7 hours, the tank is filled. 3 pipes can fill a tank in 8, 6 and 3 hours respectively. But with the help of 4th pipe, the tank was filled in 2 hours. The first 2 pipes are opened in 1 hour before the other 2 pipes. Find the time taken for the 4th pipe alone to fill the tank. It is given that pipe 1 can fill the tank in 8 hours, pipe 2 can fill the tank in 6 hours, and pipe 3 can fill the tank in 3 hours. So the capacity of the tank is 24 unit. Find out in 1 hour how much water can be filled by P1, P2 and P3. P1 can fill 3 units of water, P2 can fill 4 units of water, and P3 can fill 8 units of water per hour. There is a 4th pipe, and let's call it as P4, and we don't know in 1 hour how much water it fills. So we have 24 units. This 24 units of water should be filled in 2 hours. So it is given that the first 2 pipes are opened in 1 hour. Let's divide this 2 hours in 2 parts. The first 1 hour and the next second hour. First 2 pipes, that is P1 and P2 are opened for the first hour, and for the next hour P1, P2, P3, P4 all together, all the taps are opened. So we know the value of P1 and P2, that is 3 plus 4, which is equals to 7. And P1, P2 and P3, the values of P1, P2, P3, that is 3 plus 4 plus 8 is 15. Let's take P4 value as X. And adding up this, we can find the value of X, that is per unit of water filled by P4, which is equals to 24. That is 7 plus 15 plus X is equals to 24, and X is equals to 2 units of water can be filled in 1 hour. That is P4 can fill 2 units of water per hour. So it is asked, find the time taken for the 4th pipe alone to fill the tank. So 4th pipe alone, total work by this 4th pipe 2, which is equals to 12 hours. It takes 12 hours to fill the tank. In the next session, let's learn other interesting topic. Thank you.